Hello, welcome back. Today we're gonna solve a hard problem from Leetcode daily questions that indicates characters in string game 2. That's the upgrade version of the previous easy one yesterday. Yeah. Um. So Alice and Bob playing the game. Initially, Alice has a string A, right? I gave it a positive number.
So given that integers array operations sound unfamiliar, where operation I represent the type of operation, okay? The operation 1 equal to 0 append a copy of word itself. For example, if I think when you got ABC and you use operation 0 to copy it to ABC, right? Option 1, as normally as the previous problem, generate a new string by changing each character in word to next character in the alphabet, okay? Remember C to CD, Z, ZB to alright, ZB, Z to A and B to C, AC, alright. Return the value of the case character in word as performing the operations on the operations, alright. Alright, let's take example 2. First, you use operator 0, it's gonna copy it to AA, right? Then you operation 1, that's mean AABB, right? And then 0 is mean AABB, right? And then 1. Okay, you got the final string there, and the tenth is B, alright, B. The constraint case very large here. The previous problem case only 1000, so we can use a naive and a brute force naive algorithm to construct the string. But with this limit, you can do so because it required limited resource, limited memory. But you can see operation length is really small. Never mind. Let's go. Example you got. First of all, let's demonstrate A. For example, you got this 1 0 1 0 1 0. For example, A, you're gonna double it, right? And then 1 gonna it's gonna be B. Alright, then 0 is gonna be A B. 1 again. 1 again mean do it. Okay. A to B and C, and gonna be B and C. Okay, I think this enough. It's too long for me. Okay, I'm gonna delete it. Okay, we draw a line here. Alright, you can see. You can see after each operation, the length of this double. So it's double. That's mean after the each operation, you're gonna retrieve the A length. This length. Okay, you can see. This is initial 1, and after first operation you got 2. That's mean it's about 1. After the second you got 4. Next you got 8. And then you got 16, right? So we call this. And another point you need to consider, you need to notice here is you can see after each operation is double. It's just double. Alright. For the 0 operation, it just double, and for the 1 operation, is double but shift to the next character, right? For example, this one, it double this, that to AABB, but plus 1 shift to next character. That's it. AABB gonna be BBCC, and AABB gonna become BBCC too. Alright, so we can trace back. Alright, we can trace back it. Why? And actually we only care about the half. For example, if the k here, you can determine which is here is. So you think it just double up the half, the left half. So let's trace back to the left one and see that is the third 1, 2, 3, 4. That is the fourth characters in the right half. So it means it also be the third one in the, I mean, in the fourth one in the left side. That's it is, right? Because after double, you're gonna get the same position if we divide a middle in the middle. And because this is originally one, so it must be plus one, right? You can see this is B, and B plus one becomes C. All right. And then, but actually you don't know what is this character because you don't have any information about this. Just do it again. Know that each characters belong to exactly one group. What do I mean group here? That is after you reflect, and I mean you double it. For example, this one, it turns out it belong to, is the double of the previous half. That means this one. All right. That is, and this is to achieve this, you got option one because it at the, maybe the index is 4, so it must be locked. It must created after it must be created after the second operation, because after the second operation you got the length of 4, so it must belong to the second operation. That means this, and you know which operation, which value of this operation, that's what. So you can prove that the left half of this one is just increase, shift to the next one. So you can see it's b a plus 1, and you got b combined with this, please. So it means you have to shift now, but now let's jump back to this operation and we trace back, and from this, you know, it index is 2, and it must belong to the first operation, because after the first operation you got the length of 2, and use what I said before, it's just a double of the left side. So check on the left side at the same position, that's this is 1, and the left side this is 1 2, and it also the initial string is A and option is 0, so it's just double, so A become A. And okay, after this trace back process, you can see that A become A plus, then A become B by plus 1, and then B becomes C by plus 1. So the final answers of the K portion is C, as we have this E B because A plus 1, alright, and this is A because A double, so A become A. So it's very simple here. It's not that hard. It's not a hard problem. If you think carefully, you try it, you write the string out, and you can see the double side is increased, double and double and double. So from the right half, you can determine its value by consider the left half. Okay, let's implement it. We iterate until we meet the original string, and that means the case is 1. Alright, and we're gonna calculate the index. Let's check here. For example, at this, let's see, 1 2 3 4 5 6 7 8 9 10 11 12. It's gonna be log 2 12 because it's just power. Okay, you got 3. Alright, 3. 1 2 3. It actually is 4. Actually the index is the ceiling log 2 of K. Why we got that? Just some try and error. I mean, because our length is 22 power I, and we need to find something I that's cover the K, right? Next, so after log them, it's gonna be log 2 K less than I. This is I, and so just get the log and try to string up. Why we string up here? We not string down because it's an integer. If we see it down, it's alright. It's in down. We also need to find the maximum I. You know, maximum I. So we string up. For example, if at the position 16, it must belong to the 4, right? And 15 It's belong to the 4 too, but you see you get the log of 3.9, and we need to seal enough. So it's just about ceiling to k f. I mean, mm, uh, because there's a guarantee here. Case is the in the string word after on operation. So never mind about the battery checking here. So we need to find the length, because from the length, this we know the length of this, right, and as well as this, and we know the index of this, so we can determine the index of this. For example, this is k, and then the index of that positions must be it's like from this you plus k, and you got this, right? So from this you minus l to back to this, so it's gonna be index. Why use this operation here? This is equal to 2 power index, and if it's overflow, nah, because k is to 4 is about 56, and I mean 46 is really small. We can use this bit operation because the long because long have 63 bits. All right. K minus f the operation. We need to store the shift here because exit must also increase by 1. So shift the operation I index is 1. That means we shift with increase from previous character, we increase 1. For example, this previous character is C, so it will increase 1 to become D. And minus index, because you jump back from this K to K minus L, that means you jump back to there. And then you jump back, and then you jump back until you meet the first element. Alright, and now the answer is shift. That's right, because you have shift this time, so it must be plus shift, but you remember we from Z we could become A, so we need to modulo by 16. Oh, I got just some problem with record. Alright, can you see again? Okay, this is my code. As you can see, sorry, what happened with this one index? Alright, check. It's -1 because we index from 1. Okay, FPS line again. First of all, we need to iterate until we meet the first element. That's why we got you condition k larger than 1 here, and okay, and we need to calculate the index as I explained here. We need to calculate the index, then determine which operation you does, and if that's 1, we need to shift one character, so we need to store it. Yeah, shift here. After that you can after that you jump back to the case minus L, jump back to the same position at the left side. Alright, submit. %100%. That's amazing. Alright, but can we optimize the space? I think yes. Oh, why is it is the memory is even larger? Oh, never mind. Okay, just come back to previous solution. Alright, it's bit 100%, so it's very optimal. Okay, it's a time complexity of this problem. Oh luck, because after each ocean you decrease by half. You jump back to the half one and jump back to half one, and it's all gonna be log n of k, log 2 of k. And the space memory 0 or 1. Has a nice day.